Hey, we have here today another integral. This one's from MIT Integration Bee 2010, problem 16. We have the integral from 0 to 1 of dx over x to the fourth minus 13x squared plus 36. Okay, and this is an integral I actually did just like a week back. I can provide a link to the other video, but I wanted to do it this time a different way. The first time I did this, I was using partial fraction decomposition. And this time around, I'm just going to provide an alternate to that method. So let's get started with this. What I want to do to begin is multiply my numerator and denominator by 1 over x squared. And this is really going to change the shape of things. So when we multiply this through, we're going to have 1 over x squared dx in the numerator, multiplying this part in. We're going to have x squared minus 13 plus 36 over x squared. What I want to do is factor this a couple different ways. So one way I'm going to use is I'm going to write this as x minus 6 over x squared. Notice when we square that, we get x squared. We get plus 36x squared. The middle terms together are going to give us minus 12, but we have minus 13, so I'm going to subtract a 1. Now the other factoring I want to use is really similar. I'm going to write this as, nope, not that. We'll write it as x plus 6 over x squared. Again, noticing this is going to give us our x squared, our 36 over x squared, but a plus 12. To get from plus 12 to minus 13, we need to subtract off 25. And what I'm trying to do with all this is I'm trying to set up a u substitution. And how this is going to look like, if this is going to, I'll say this is going to be a u, and we'll call this t. If I take the derivative of this, our du is going to be 1 plus 6 over x squared. And then over here, this, if I take this derivative, dt, it's going to be 1 minus 6 over x squared. So what I want to do is I want to get this and this into my numerator, even though it's, I mean, we have a 1 over x squared, but we don't have this. So it's like, okay, we need to kind of force this to happen. Let's just bring this up here and see how it looks. So now creating my numerators this way, and I'm setting this up to be 2 integrals, by the way. So if we add all these together, we've totally changed it. We have a 2 instead of a 1 over x squared. But if I subtract these two expressions, all right, then the 1 and the 1 cancel. Okay, that's good because we don't have a 1 here. Because we have minus times minus, adding 6 over x squared to 6 over x squared, we get 12 over x squared. Well, we have 1 over x squared. But remember, I could write this, I could change this to a 12 over x squared to make it work and just divide or multiply by a 1 over 12 up front, so I'm not changing it. And so that's exactly what we're going to do. We're going to just have a 1 over 12 in front of an integral. And then here I'm going to do the same thing, but I need a little more space. And here we'll have a minus 1 over 12 in front of this one. So again, notice if you put all that together, you'll notice that we still come back to our same original 1 over x squared. But from here, what's our denominator going to be? Well, it's going to be this thing, but we have it in two different forms, and we want to use like the appropriate one. So like we've already set up our du here, so we want to use this one here, and then we'll have this t set up over here. So let's see how this is all going to look. Okay, so now you see writing it this way, we have it where we're going to have the derivative of this in our numerator, the derivative of this in our numerator, and I think we're ready to make a u substitution and t substitution. I have my values here for u and t and the derivatives, and so now we can go ahead and rewrite our integral with the substitution. Now first, on the first one here, let's update our bounds. So plugging a 1 in here, we have 1 minus 6, so we're going to have a minus 5 for the upper bound. Then the lower bound, we're going to plug a 0, and we have 0 minus 6 over 0. Normally dividing by 0 is no good, but we're looking at it as a limit, so this thing is going to be approaching minus infinity. Then we'll have our du in the numerator, and then our denominator is just going to be u squared minus 1. Now for the second integral, we're going to plug a 1 in here. We'll have 1 plus 6, so our upper bound is going to be 7. Then we'll plug a 0 in here. Same situation, we're going to be dividing by 0, so we have 0 plus 6 over 0, but that's actually heading towards infinity. Then we're going to have our dt. This whole thing here is just dt, so we'll have that in the numerator. And then in the denominator, we're going to have t squared minus 25. And one thing I'm going to do before we continue, I'll change the sign here just in order to flip my bound. So we'll swap these. And now the good thing here is we get two pretty easy integrals. These are pretty common, so I'm going to use a formula for these, but let's just take a look at that formula first. Okay, we have this nice formula down here for this integral, and notice this works for both these. We have perfect squares here. I can write this one as 1 squared is 1, and we can write this, let's just rewrite 25 as 5 squared. So that way here our a value is going to be 5, and here our a value is going to be 1. So we have everything we need in this formula. So then let's just go ahead and use this now. So first we'll have, let's just bring a 1 over 12 out in front of everything. So then let's focus on the first one. We're going to have, using this formula, we're going to 1 over 2a, but a is just 1 here, so we're going to have a half natural log u minus 1, u plus 1. And this is from minus infinity to minus 5. And then here, let's look at the second one. Keep our 1 over 12. Then integrating this, we'll use the formula again. So we're going to have 1 over 2, but now we have a 5, so we're going to have 2 times 5 is 10, natural log, and then we're going to have t. Doesn't matter what variable we use, but we'll stick with what we have. So we'll have t minus 5 over t plus 5. Then let's evaluate this. So 1 over 12 times 1/2 is going to be, we're going to have a 1 over 24 in front. Plugging in our upper bound, minus 5 in here. So we're going to have natural log, and this is going to be minus 6 over minus 4. Well, that's the same as 3/2. And of course, I can remove the absolute value on that. Then next, we're going to evaluate this at minus infinity. But you notice if you plug minus infinity, you have minus infinity on the top and the bottom. So the whole thing inside here is heading towards 1. Natural log of 1 is 0, so we don't have to worry about that. Then here, 1/12 times 1 over 10 is going to be 1 over 120. Okay, we'll plug our infinity. First, we'll plug our infinity in here. Notice, basically infinity over infinity is heading towards 1. So that part's going, this piece, natural log of 1 is 0. Then for the next part, let's bring our minus 1 over 20 over so we don't lose it. We'll plug a 7 in here. So we're going to have, we plug 7 and we're going to have 2 over 12 or 1 over 6. Okay, now at this point, this is pretty much fine as an answer, and you could represent this a whole bunch of different ways, but what I want to do is try to get it to look like the answer we had in the previous video. Their simplification was to get things in terms of just natural log 3, natural log 2. So I'm going to do the same thing. And first I'm going to do, we can look at 1 over 6 as 6 to the minus 1 and bring a minus 1 up front, so I can change this sign to a plus and then just make this a 6. But then of course 6 is the same thing as 3 times 2. Everything we have here is 3's and 2's inside the logarithm. So then using log properties, we'll write 3 over 2 as natural log of 3 minus natural log of 2, but let's not forget this, 1 over 24. And we'll do the same kind of thing over here, just making this natural log of 3 plus natural log of 2. And then notice if I multiply by 5 over 5 here and 5 over 5 here, I can get the same, this common denominator of 120. So we'll have a common denominator of 120 in every expression. Okay, and then from here, all I want to do is put together my natural log 3 terms, and we got our natural log 2 terms here, so we can combine those. So 5 over 120 plus 1 over 120 here on the natural log 3 is going to be 6 over 120, but that's the same thing as just 1 over 20 natural log of 3. And then here we'll take 1 over 120 minus 5 120s. It's going to be minus 4 over 120, but that's the same as minus 1 over 30 natural log of 2. Let me check my answer because Yep, that's correct. So that's the same answer I had in the other video, the same answer that MIT has. If you'd like to see this using partial fractions, I'll provide a link in the description. Also, let me know which way you think is better or faster. I actually don't really have, I think they're both about the same. Maybe this might be a little longer. I don't know. So I guess I think if I get a vote, I'm voting for the partial fractions, I think. Anyway, that's it. Thought it was fun doing it this way. So appreciate everyone's support. Thank you for watching. Have a great day.